Hi everyone, welcome to Code for Community's workshop on source control in Git. Before I get started, if you're someone that likes to learn through reading instead of going through these videos, we have a written version of this presentation along with the slides I'm going to present available at learn.c4cneu.com. That's learn.c4cneu.com. So let's just jump into it. So the ideas that we're trying to cover today: what is source control? What is Git and what makes it a good source control system, and how we can use Git in our development cycle. I'll say right now these slides are going to last about 20-ish minutes, and then we'll have a demonstration that'll go all the way up to merging in with merge conflicts in our presentation. So what is source control? Source control, you'll also sometimes hear it as version control, is basically just tracking and managing changes to a code base. And a source control system is just a systematic way of handling that. So what is that good for? Why do we want source control, and why do people talk about it so much? Well, for one, it helps us add new features without disrupting existing ones. It lets us track the history of our project so that we can look back to older versions of it. It allows multiple developers to collaborate on the same code base at the same time a lot easier. And if we ever do introduce bugs, having that history there lets us easily track down when it might have been added. So just to give us some context on what a source control system can be, let's start off with a very basic source control system, a very basic and very bad source control system. So let's say your code base is just a big directory full of all your files saved on your computer. You want to make a change, but you're scared of breaking what you already have. So you're going to copy all of your files into a new directory and make your changes there. If you need to make different changes, just copy all the files into a third directory and make them there. That way, every time you have a change, you have a different directory that shows you building upon that. So why is this a bad idea for source control? Well, essentially, it's a bad idea because you're going to waste a lot of space, for one. You're going to have a lot of repeated files every time you make a change. It's going to be very hard to keep track of. If you're just going to have a million different directories on your computer that follow each of these changes, it's going to become very easy for you to get lost and not be able to easily track down a change. It's also going to be very slow because you have to copy all those extra files. It's going to take you a lot of time every time you want to take one of those screenshots and copy all your files again. It's going to take a long time. And there's plenty of other reasons why generally you shouldn't do this. But okay, this is a source control system, and it's something that we can work off of and compare to Git. So what is Git? Well, it's a good implementation of a source control system. And really quickly, as you're kind of learning software development, you're going to hear Git and GitHub kind of together. They're not the same thing. GitHub is a website, while Git is the system that underlies it. Sorry, this right here should say GitHub. So GitHub is a website, while Git is the system that underlies it. Think of it like YouTube is like GitHub, and Git is like a video. Videos exist without YouTube. Git exists without GitHub. GitHub and YouTube are just the platform that host it and make use of the technology. So what makes Git a good source control system? Well, for one, when we were using our bad source control system, we were tracking changes on a project level. So we were tracking that a change was made to this entire project. We could also track just when a file changes. So maybe instead of copying your entire directory, you just copy one file. Well, Git goes one further than this. Instead of just noticing when a file changes, Git is going to know what in that file changed, and it's only going to keep track of that changing thing. Git is also distributed, meaning multiple people can work on a Git project at the same time without being connected to the internet and not run into any problems. It's also very fast because we're only keeping track of the content changing the files. There's a lot less overhead there. So Git is much faster than if you tried to make a full copy. And we'll see a little bit that Git commands and the ones that we're using are very customizable. So once you get really good at Git, it's a very powerful tool and you can do a lot of advanced things with it. So before we kind of get into things, you're going to hear a lot of these terms thrown around a lot. So I want to give you some context on what they all mean. So repository or repo. A repository is just the central location where the project is being kept. You can generally interchange this with a directory that has all your files. It's essentially where all your code is. A branch, we're going to call that an independent line of work. So every branch that you have records how you wrote the code to get to that point in your project. So every time you have a series of changes that leads up to something, you can think of that series of changes as a branch. Staging is where you decide which files you want to keep track of. Git is a opt-in system. That means every time we make a change or every time we create a new file, we have to specifically tell Git that we want to keep track of it. We'll talk a little bit more about why that is later. A commit, we can think of that as the same thing as taking that snapshot of your project. This is analogous to when you were making that copy of your directory in our bad source control system. A commit is this moment in time we are freezing this in our history. And merging is when you combine two separate branches, two separate lines of work back into one. So I'll be trying to draw this out for you guys as we go. Of course, I'm only on the computer. It is currently the age of COVID, so I'll be doing this in Paint, so it might get a little bit messy, but I just want to give you guys some ideas on these three parts of Git that we're going to show. So essentially we have a blob. A blob is just the file data. It's all the ones and zeros that Git is keeping track of, so it knows what in what file changed and where it changed and how it changed and all of that. It's all of the data. A commit is, like we said, a snapshot of the project. We're going to show that with an arrow. You'll see why a little bit once we get into things a bit more. And then we also have tags in Git. And tags are a little bit more complicated. We have three types of tags. We have a head tag, which we're going to indicate with an H, which is essentially the blob that we are currently working off of. So the head tag shows us what our code on our computer looks like right now and what commit we're at. Another type of tag is a commit tag. So every time we take a screenshot, Git will automatically give us a tag for that commit, just a way of identifying that commit with itself. And then the final type of tag is a branch tag. So for each branch that we define, each line of work, remember, we define a tag that goes along with it. So just an example, like master, feature, hotfix. These are just going to point to one of the commits that your branch is currently at. And we'll see that a little bit more when we get into our demo. So let's get right to it. So I'm going to be using Git Bash for this. If you're using Windows, I highly recommend you use Git Bash as your terminal. If you want to use the command prompt on Windows, some of the commands that you see me using aren't going to work. There are analogies to them that you can look up. Git Bash uses Unix terminology. If you're on Mac, then you should be fine just using your regular command prompt, and everything should kind of work out. So the first thing I'm going to do is I'm going to move us into a directory. So we'll just call this Git practice. We'll create our directory there, and we'll go into our directory. And to kind of demonstrate Git, what we're going to do is we're going to build a very simple web page with HTML. So to do that, I'm going to create a file, index.html. I'm going to be using Vim as a text editor. Don't worry too much if you don't know HTML or don't really know how Vim works. I promise it's not super important to learning about Git. We're just going to be using this so that we have some code that we are making changes to, and we can show off some different Git features. So I'm just going to add a little starter code. And there we go. We call ls, we can see that our file is now there. And if we call start Chrome on our HTML page, we can see we have our page right here. We are learning Git and it is fun. So right now we just have a single file and a directory, and Git is not involved anywhere. We have no source control and nothing to add it. If we want to add source control into our project, well, first we have to download Git. If you haven't done that already, you can just Google Git download. It's very easy for you to do. It'll come with Git Bash if you want it to, and you can use this terminal. Otherwise, you can just download it and use it on your terminal regularly. So to make this directory a Git track directory, we're going to call git init. And we can see we have now initialized an empty Git repository in this path at .git. So do ls, we're not going to see it. That's because .git starts with a dot. A dot means it's a hidden directory, so we have to call ls-a to see all files and directories. And we can see our directory here. So this .git directory is going to be where Git is holding all that data that keeps track of what's been changing, what branches you have, where's your head at, all that type of information is all going to be stored in this directory. You never really have to worry about it. If it's there, you know Git is activated, things are going in. If you want to explore it, feel free to do it. For time reasons, we're not going to get into it right now. So the next thing you'll have to do if this is your first time using Git is you're going to have to call this command git config user.email and give it your email. This is actually my email, so don't bother trying to email this. And we also have to call git config user.name, and this is my name. So you feel free to call me by that. But the reason we have to do this is because every time we take a commit, Git wants to know who made that commit, who made this change, so that if you're going back in history, you can see itemized list of who made each change and got you to the point where you are in this project. Git can't do that if you don't actually give them your information. So that's why we have to do this as part of our setup process. So once we clear our terminal, we can get into it. You can also see that we have our little master up here. That lets us know which branch we're on. This is a Git Bash specific thing. You're not going to get this if you're not using Git Bash normally. But we can see by default, when we just call git init, we're going to be on the master branch. And let's start off by calling the most basic Git command that you're going to be using, probably the most out of any, is Git Status. And when we call Git Status, we get some information. Again, we can see we're on branch master. We have no commits yet, which is good because we haven't done anything. You can see we have some untracked files and nothing added to our commit, but there are untracked files. So, like we said earlier, Git is an opt-in system. We never told Git that we wanted to keep track of index.html, so it's not going to do it. So why is Git like this? Essentially, it's because you're not going to want to have source control on all files. Things that contain sensitive information, like passwords, you never want to include in Git. By default, Git is public, so if you have things like passwords, keep them out of Git, and especially GitHub. Other things like generated files, if some of your files have to create a bunch of other files as part of their kind of build process, you never want to check in those generated files because it's just going to add a bunch of data, and because it's not actually going to be changed by user, it's going to be useless. You're just going to clog up your practice. So, how do we tell Git that we want to track this? Well, we just have to use the Git Add command. So if you say Git Add index.html, we get a little warning that we can ignore. It's just because of my text editor right now. But we can call Git Add, and now if we do Git Status, we can see our changes to be committed now includes index.html. This is staging. This is what we call staging, with our file ready to be committed. Once we want to commit it, we can call git commit, press enter, and we'll be immediately taken into a text editor. The reason for this is every time we make a commit, Git wants us to provide a message for our changes. We can see it giving us instructions right up here. And this is just so that when you look back in your history, you can see each of these changes, you can see what happened, and it just makes it a lot easier to keep track of what's been going on. You should always try to make these messages descriptive and easy to go back to. It's going to save you a lot of hassle if you ever have to come back in your history later. So for right now, we can just say initial commit. And we've done it. We have done our first commit. Now, the last big command that we're going to show for right now is called Git Log. And Git Log is going to let us look at our history. Let me do that a little farther up. So, right now we have a single commit. We can see commit, a big string, head, arrow, master. You can see the author is me, the date is right now, and our message is initial commit. We can also call Git Log one line. That's just going to give us a shorter version of this. It's not going to show us the author, and it's not going to show us the date, which is okay since I'm going to be the author for all of these, and the date is all going to be about right now. We can still see our message, and we can still see our head is pointing to master. So let's try and draw what's going on right now. So I've got Paint open over here. We can select our brush. I have some kind of tags that we're going to use later, just so that I don't have to make them in the moment. And so we're going to draw our working tree. So this is going to be drawing our history. So we just made our first commit. So we're going to draw a little circle for our blob, all of the file data that we just included. And we're going to draw our commit tag just right inside of our blob. So you can see our commit tag is this value right here. You can use the short version or you can use the long version. Git will kind of know how to handle both of them. For our cases, we're only going to draw a much shorter version. We're just going to say A. And now we already have some tags pointing to our first commit. We have our A tag, which is our commit tag, but we can see by default, Git is also going to give us a branch tag that's pointing to it. So we'll just draw a quick arrow here. That's because we can see master. That is our branch tag right now, and it's pointing toward the initial commit. And we can also see our head tag is pointing at our master tag. So if we go back here, let's move our head tag out and give it its own little arrow. And notice how it's not pointing towards the commit directly, but instead it's pointing towards a different tag that points at the commit. We'll see why this is important a little bit later on. But okay, this is all pretty cool. But let's make our history a little bit more interesting now. So to do that, I'm going to add 2 pages. The first one is going to be an About page. Stick with me here while I am typing along. I think that about sums it up. And we can save this. Let's also make maybe a skills page. Call this My Skills. Pretty good at coding, I like to think. Also pretty good at ripsticking. Love a ripstick. Oops. And once we get our indentation right, there we go. So let's run Git Status. Like we said, we never told Git about, or skills, so they're untracked. Let's change this. We're going to call Git Add. We'll use star here, the asterisk, to just say that we want to add everything. Everything's there, and we'll commit it. And instead of going to our text editor, we're going to use this -m flag and just specify our commit message right here in the command. So we're going to say add an About page and a skills page. There we go. And let's maybe add one more thing before we start looking at our history. So we want a way of actually getting to our pages. So let's just edit our index page. And we can add a little list that just includes some links to our other pages. Oops. All right. We can see that even though index was a new page, again, even the changes have to be opt-in. So we'll have to add this to staging first. And now that it's in staging, we'll just call git commit -m added page navigation. Let's just try this out real quick, make sure things are working. Ideally, you probably want to do this before you ready to commit, but it's okay, we won't beat me up too much about it. So we can see, yep, this all checks out. Great. So let's look at our history, called Git Log. We can see some things changed. We still see our initial commit. We now see our added an About page and a skills page commit, and our added page navigation commit. And our head and our master are now up here. So essentially, if we go back to this side of things, we're going to add 2 new commits. First one is B, and we're going to draw an arrow back from B to A. The reason for this is because this blob that B is in again, we said Git is only going to keep track of what changed about the files. So B is only going to keep track of what changed between where the project's at commit B versus where it was at commit A. So we committed that, and then we also committed a third one called C. We'll point that to B because it's only keeping track of what changed from C to B instead of keeping track of all the other files. And then our master and our head tag both advanced with us. All right. So let's do one more thing. Let's say our boss at our company that we're working on decide we want to work on a new color feature. We're going to add colors to all of our pages. We say, no problem, we can do that. So what we're going to do is, we're feeling pretty good. So we're just going to go right into index.html. We're going to make that change. We're going to go up to our href. And again, don't worry if you don't understand the HTML or CSS stuff that I'm writing right now. It's all fairly basic stuff, and you may run into it in the future. So we're just going to say color equals red. This time, maybe we should check this beforehand. We can see, yep, our color is red. Awesome. Let's just commit this one as well. Added red color to .html. And of course, we kind of get the deal by now. We add a new commit, point back to C. Our master and our head tags are going to move up and now point at D. We can confirm this by looking at our log. Yes, we now have this fourth commit, and our head and master tags are up here. So this is all well and good. We're keeping a history, but what happens when we want to actually look back at our previous pages? Say we added our red color, and we want to add colors to our skills and about pages eventually, but our design team is still kind of working on what they actually want to add, so we're just not ready for that yet, and we don't want to be adding red color to the index if we're not going to have the other pages yet. So what we can do, we're going to call a new command called Git Checkout. And what Git Checkout is going to do is it's just going to move where our head tag is. So when we call Git Checkout, all we have to do is give Git a new type of tag where head should point. Unlike a commit tag that points directly to a blob of data, a head tag always has to point to a different tag. It's the same thing with master, but master can only point to commit tags, or branch tags can only point to commit tags. Head tags can point to branch tags, and they can also point to commit tags. So I'm saying tag a lot, so let's actually see what's happening. So we can copy this commit tag, say git checkout fa27 blah blah blah. We call this, we get some warnings that we're going to talk about in a second. But now what we do, we'll call Git Log. We'll see, okay, our head is now at this commit, added page navigation, and it's no longer pointing to master. So over here, what we did was move head, so now it's pointing right here. The other thing we'll notice right off the bat when we're calling Git Log is that we can only see 3 commits now. That's because at this commit, we can only follow the arrows of our tree down. We can't see anything unless we have an arrow pointing to it. So D points to us, but we have no arrow going from C to D, so we can't see D. And this makes sense because C is building on top of B, but D is building on top of C, so C doesn't really care what's pointing to it. It only cares what it has to see to actually know what the history is going to be like. So awesome! With our Git checkout, we can now point to different tags. And note, just because we can't see our fourth commit and we can't see our master, we can still call Git checkout. Maybe we'll say master this time, point to a branch tag. And just like that, our head is back to where it was. This got moved back up to here. But like we said, we're still waiting on the colors, so let's go back to here. And let's look at this message that we have right now. So we have our color commit. Our team also decided they want to start working on a quotes page. So what we could do is from right here, we don't want to build the quotes page on top of our red commit because we don't want the color in yet. We want to build it right here, but we don't want to just start willy-nilly. That's because, as Git so helpfully tells us, we are in detached head state. So Git lets us point our head tag at commits, but it really doesn't like it when we do. Why is this? Well, so think about what would happen if we were to make a commit right now with our head pointing towards C. So if we were to make a commit, we'll call it E over here. E is built on top of C, so it's going to point back here. And our head tag is going to move up so that it points to our, oops. I guess I can't really work with this arrow, but we'll make a new one. So our head tag is now pointing towards E. Well, so what happens now if we're working on E and then all of a sudden, oh, our design team has our colors now, so we can move our head back to master so that we can add those last two colors. We move this over here, but now we're kind of stuck. If we look at our D, we follow the arrows down, no arrows point to E now. E is completely on its own, so essentially we have no way of getting the E tag back and no way of moving that back into our working directory. All this work right here would essentially be lost. So what do we have to do? We delete this, move our E back to where it's C. Well, essentially this is where branch tags come in. This is where branches become useful. So what we're going to want to do is instead of pointing our head straight to C, we're going to want to create a new branch tag, which we'll call feature. And we want to point feature to C and point our head to feature. This way, when we do eventually create this E commit, it's a little smushed up, but you guys know your ABCs by now, I hope. Then our feature is going to move up, our head's going to move with it, and if our head has to move back to master now, then we'll always have our feature branch pointing to E so we don't lose this work. So let's go and do that. So the first thing we have to do, we have to create that feature branch tag. So the way we do that is we call git branch. And we say git branch feature. We can also call git branch without any arguments, and it's just going to show us all the different branches that we have. So we have our master branch that was there before. We also have our feature branch and our head, which Git is telling us is detached right now at this commit. So if we want to move our head so that it's pointing towards the feature tag, all we have to call is Git Checkout feature. And now we can see it's no longer going to give us this, but it's just going to highlight the feature branch to show us our head is right there right now. We can also look at this in the log. And say, and we can see once again our head is pointing towards feature. So we said we wanted to add a quotes page. So let's add a quotes page. We're going to jump back into Vim. Develop this feature real quick. Just add a couple things that I've said. Coding is fun. We have to add our quotes here. Rip sticking is cool. I refuse to take any other opinions on that. Awesome. We have our quotes page called Git Status. There we go. We can see we're now going to add our quotes and commit. All right. So right now our working tree in Git is now the same as our working tree in our little paint project, which is fantastic. And so now we said, oh, our design team just got back to us. They actually have the rest of the colors ready for us. So what we're going to do, we're going to leave our feature right now. We're not sure if we're completely ready to merge it in just yet. So we're going to call Git Checkout Master. You can see our log, just make sure everything's okay. Yep, our added red color. You can still see our 3 previous commits. Again, notice that D is not pointing towards E at any point. So this is exactly expected that we would not see it. Point. Just quickly get rid of this and draw an arrow. So let's add some colors. We decided our index page, we're going to make this maybe green. Our skills page, maybe a purple is what our team decided. Of course, let's add everything, commit it. And now we can see that's okay. Our master is now pointing towards F, and our head is pointing towards master. So this is great. We've got our master branch going, we've got our colors, and we still have our feature work saved. But so what happens when we want to actually merge our feature work, we want to get our quotes page back into our master branch? So we have a couple different options with this. Essentially what we can do is we can either rebase or we can merge. For right now we're only going to be working with merges. Rebase essentially would have us rewrite our Git history, which you can do sometimes, but a lot of times rewriting history is dangerous and you're losing a lot of work. So instead of calling rebase, we're going to merge. Let's just move this down a little bit. We know where A is somewhere down there. It's okay. So what do we mean when we say merge? So we want a new commit, and we want the commit to be aware of E, and we also want it to be aware of F. So what we're going to do graphically is we're going to have our blob G, and instead of now, before we've only had it pointing towards one place, we're going to have G point towards F and E. So G is going to know the changes in F, know the changes in E, and G is going to know how to reconcile the two. Take both the changes in these two independent branches of work and put them back together. So the command to do this, self-explanatory enough, is git merge. When we call git merge, we have to give it a tag. And this has to be a branch tag. So we're going to call git merge. Right now we're on the master branch, remember. I'm going to go git merge feature. Even though these merges are a different kind of commit, they're still a commit. We're still drawing a blob and we're still drawing some arrows, so we still have to give a message. By default, when you call merges, Git will give you this kind of default message, merge branch feature. A lot of times this is fine. If we want to add a more descriptive message, we can, but we're fine with this message, so we're just going to save the file and log out. And now let's look at our log. So some interesting things here. Things that we notice. We have this new commit called merge branch feature. And we can see our head and our master are still pointing towards it, are now pointing towards it. So this all moved up. And now we can see both our added colors here, and we can see our added a quotes page just kind of stuck in the middle. We can see our feature branch is still pointing towards it. So when we called the merge, this tag did not move. It's still pointing here. Some people get kind of confused about the way, the order that it's showing up in. Essentially, this is just because when you have these kind of two separate paths, there's no distinct way of kind of ordering those two different paths. So instead, Git just uses the timestamps that it's taking. And remember that we added these colors after we added the quotes page, so it's just going to show up higher up in the history. So there we go. We did it. We've merged our features. Let's just maybe look here. We can see our quotes page is right there. And then we can also call start Chrome. We never added navigation, that's okay. We can see our colors are working great. So this is where we're going to stop for right now. We've gone through a lot of different material. We've introduced kind of the concept of Git and source control. We've talked about commits. We've talked about our different types of tags and our branches and how we can reconcile them all with merges. And this, for the most part, is a large majority of what Git is. There's a lot more fancy tools, and things get a little bit more complicated when you're working with remote servers, with GitHub and kind of remote things. But all the ideas that we've just seen right now are pretty much everything that you're going to encounter in the future. So I'm going to end this off right now. Thank you guys all for watching. If you want to learn more about this, on our learn.c4cnu.com website, we have the notes to this presentation, and along with that, I've included some extra materials, some really helpful resources that help me learn Git that you guys can follow along with too. So thank you all for watching. Have a great night, guys. Hope you learned something from this.